Okay. All right, guys. I cannot minimize Zoom. Yes, I can. I should be able to minimize it. Sorry, guys. It says I can't minimize this, and I should be able to. Oh, because I'm not sharing the screen. There we go. Okay. So what I'm going to show you guys today is how do we look and do like scatter plots? How do we get a correlation coefficient? How do we go through and get residuals and those sorts of things? Okay. So I'm just going to make up a set of data, and then I'm going to show you guys how to get a scatter plot for that data. It's actually pretty easy. Okay. So let's say, I just have the numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, or not 120, 11. And then let's say I have the numbers, I'll just say 5, 7, 10, 13, 15, 16, 19, 22, 24, 25, doesn't matter, 29, 31. Okay. So if I have a set of data, what I can do is I can just highlight the data, go up to insert and insert a scatter plot. It's actually pretty easy to do this. Okay. So, and some of you guys have already been doing this for the assignments. Okay. So what you guys are going to do, you're going to highlight all the data. You're going to go up to insert. And then right here is a scatter plot. I know it's tough to see. All right. But it's this very last one right here. Okay. So you just click on that. All right. And then let's click on this first scatter plot. All right. So, and I'll do it again just to make sure everybody can see it. Again, not meant to be too difficult. Highlight the data, go to insert, click right here where it has the scatter plot and click on scatter. Okay. So nice and easy, right, guys? If I was to ask you all to describe the strength, direction, and association of the scatter plot. Okay. What would you guys tell me about the scatter plot? Strong. Absolutely. What is it, Dora? Positive and linear. Okay. Does that make sense to everybody? We know that, right? If I want to put some labels in here, just like I do with the histogram, bless you, what I'm going to do is I'm going to click on the plus, and then there's this axis titles that I'm going to click on. Okay. And I know it's small again. I apologize. All right. But you could just go up here, change the chart title. Okay. So whatever you want to change it to. So we'll just say example from class. All right. Boy, I can't spell. From class, and a comma. Okay. And then whatever the X variable is, it's going to go here or the Y axis. So that'll be the Y variable. So I'm just going to say Y variable. Sorry, guys. Yeah, it's sideways. So when you hit backspace, it's weird. All right. And then X variable, whatever you want to call it. Okay. Now, if you want to get the correlation coefficient, and also if you want to get the least squares line, okay, so remember you had like the B1 and the B0, and you guys did those formulas. Check this out. What you guys are going to do is you're going to right click, okay, so not left click, but you're going to right click on any of the dots, and you're going to go down here to where it says add trend line. Okay, so, and I'm going to do this again. So if you want to watch the first time and then, or write down and do it again. So I'm going to click on add trend line after I right click, doesn't matter which dot. Okay. Over here, there's going to be some options. You guys are going to click the last two options. It says display equational chart, display R squared value. Okay. And notice what happens is on the chart, I'm going to unclick them and click them. Okay, you're going to get these, and I know you guys can't see those. All right, so let me blow it up so that way you guys can see it. Font 9. Okay, there we go. What that does is it gives you the least squares line. Okay, or this guy right here. So it automatically gives it to us. Okay, so remember, guys, you had to type that in your calculators. You could get A and B, or you could use B1 and B0 formula. Now you can use Excel to get that. Okay. Now it gives us the R squared value, but it doesn't give us the R. Okay. So if you have a square of something, how can you undo a square, guys? Take the square root. Okay. So to get the correlation coefficient in any cell, what you guys are going to do is just type equal SQRT. That's the square root function. And then just type in whatever R squared is, 0.9915. Okay. Now, Darvin, you told me that this is a strong positive linear association a moment ago. Correlation coefficient is 0.9957. Okay. Isn't that like almost a perfect association between two variables because it's almost one? Okay. And notice, guys, that we only have a few dots that are even close to off the line. Most of the dots are actually on the line. Okay. Let me do that all again, just so everybody can see it if they're trying to take notes and stuff like that. So I'm going to delete this. All right. And then I'm going to delete the line as well. All right. So again, what you guys are going to do is on any dot, it doesn't matter, you right click on the mouse. Then you go to add trend line. The last two options, display equational and chart, display R squared value. Okay. You don't have to blow these up. You can move it around, but I'm going to make it bigger. So that way you guys can see it. And then the last thing you guys are going to do to get the correlation coefficient, actually there's two ways to do it. I'll show you guys another one. You could type equal square root of 0.9915. Okay. Another way to do this, for those of you guys that need to do it without getting the chart, is you could type in this function, equal CORREL, coral, okay? And then just highlight the first set of data, comma, highlight the second set of data, all right? And what happens is, notice guys, we get the exact same number, okay? It looks like it truncated it a little bit, okay? It's almost the same number, all right? So that's another way that you guys can get the correlation coefficient, okay? So I don't care which way you guys do it, just showing you guys two ways. One way to get it with the chart, one way to get it without, okay? All right, any questions so far, guys? Okay, go ahead, no, I'm sorry.
When you put the trend line, is it very clear what is the trend line versus like what would be the derivative of a certain?
Yeah, absolutely, yeah. And because we're not modeling it with a polynomial, you know, we wouldn't be doing that anyway, okay? Yeah, that's more advanced stuff, okay? Other questions, folks? Okay, now another thing I'm going to ask you folks to do is to get a residual plot, okay? And you guys probably remember that to get a residual, what did we have to do? First of all, we had to use the least squares line, didn't we? And we had to plug in all the X values into the least squares line, okay? So we're going to get Excel to do that for us, okay? So I'm going to make a new line here. All right, so I'm just going to call this the X data. I'll call this the Y data. Blow this up a little bit more so you guys can see it. Okay. All right, I'm going to call this the Y predicted column. And to get the Y predicted, here's what I'm going to do. I'm going to type equal, and then I'm going to type in this formula, except when I get to X, I'm going to type in A2. Okay, so the cell where the first number starts for the X data. Okay, so I'm going to type in equal 0.25 or 2.5, excuse me. Oh, I'm not typing anything. 2.5909 times A2 plus 1.9091. Okay, now you guys are going to have a different formula, right? So what all you guys are going to do is just type in whatever formula you guys get, and you might have like, you might start like cell A1 or something like that, okay? And regardless, what that does is that this function gives us what the Y predicted is, okay? Now check this. See this little black box in the lower right-hand corner? I'm going to drag this box, and it's going to do that for every single cell. So we don't have to type it in every single time, okay? So you just expand that, and Excel follows the pattern, okay? So let me do that again for you guys. All right, so for the Y predicted, I'm going to type equal, and then 2.5909 times A2, that's the first X value. So whatever cell the first X value starts in, that's what the cell you're going to type is, plus 1.9091. Once you get that, you're going to take this little black box here and you're going to drag it. Okay. All right. So that's how you get the Y predicted. Okay. The next thing we need is the Y actual. Okay. Or I'm sorry, we need to subtract that from the Y actual. Okay. So this is going to be the residual. Okay. So for our residual, what I'm going to do is I'm just going to say that's going to be equal to the first residual, which is in cell C2. Okay, so you guys can see column C, row 2, minus the first Y actual, which is in cell B2. Okay, so does that make sense, guys, when we're doing this? To get the residual, you take the Y predicted minus the Y actual. Okay, and it gives us that negative 0.05. And then just like we did for before, we're going to drag this. Okay. I want you guys to notice that all the residuals are pretty small, okay, as they should be, because isn't the correlation coefficient close to 1? which means that they're all really close to that least squares line, okay? If we start having like lot points that are further off, then we're going to start getting bigger residuals, okay? All right, so far, okay, guys, I'll do that one more time just to make sure everybody's good. All right, so go back, and I'm going to say equal C2 minus B2, okay? So that's going to be Y predicted minus Y actual. I guess it should be B2 minus C2, so B2 minus C2. All right, it doesn't matter because we're going to be taking the absolute value anyway, eventually. So, but it should be Y actual minus Y predicted. All right, and then we just drag it. There we go. All right, now we still need to get a residual plot though. Okay, so we've computed all the residuals. Now to get a residual plot, what I need to do is I need to name those like E1, E2, E3, or R1, R2, R3, whatever you want to do. So what I'm going to do is I'm going to move this over. So I'm going to take this, just kind of cut it and move it over like a column. It might be better for you guys to do this. Like when you guys are doing it, just make a row, a column that has the names in it. So I'm going to say this is the name of the residual. I'm going to call it like R1, R2. And then I think Excel is smart enough that if I drag from R1, it'll just say R1, R2, R3, R4, R5, etc. Okay, so make sure you guys are using that function instead of just typing all that stuff in by hand. I mean, you certainly can, but I wouldn't. And then finally, what you all can do is you could just highlight this data just like this. Okay, and then I'm going to insert our scatter. It should work pretty well. All right, and there we go. We get a residual plot. Okay, let me blow that up for you guys. All right, remember, a residual plot just helps to see how far off the residuals are. And remember, we talked about like suspect points. Doesn't it look like the 10th observation might be suspect because it's pretty high, and the 6th observation is suspect because it's pretty low, okay? But again, because the correlation coefficient is so close to 1, there really isn't any suspect data, but in relation to all the other data points, okay? All right, let me do that again just to make sure you guys are all good getting the residual plot. Because on this assignment, this is the toughest part. Okay, once you guys get that, the rest of it's not so bad. Okay, so let me get rid of this. I'll get rid of the residual itself. In fact, I'll just get rid of everything.
Quick question. Do
Yeah.
you know how different this is on Mac?
For this part, it's not much different. Okay. But for some other functions, it might be like, for instance, the stuff that we did last week, that's a little bit more different. By the way, guys, you got, if it's so different that you can't do your assignment on a Mac, I would go to library and just do it on one of the PCs. Okay, that might be the best thing to do if there's any
I checked on the
discrepancy.
stuff last week. It wasn't terribly different.
Yeah.
It was easy to figure out, but I was just curious.
It is a little bit different
Okay.
though on a Mac, and I apologize. You know, I'm a PC nerd, so it is what it is. All right. So first thing you guys are going to do is you're going to get the Y predicted. And that's going to be equal to, remember we had 2.5, I forget the number. Sorry, guys, there it is. So we have our plot, so that's going to be equal to 2.5909 times A2 plus 1.9091, bless you. Then you're going to drag, in fact, you don't have to drag it yet, but you can, okay? Then you're going to put in the residual name. And you're just going to have like R1, and then you could just drag that. And that should, and Excel should be smart enough to do that. And then finally, you're going to get the residual by subtracting B2 C2. Okay, so equals B2 minus C2. And then you're just going to drag it all the way down. And then finally, to get the residual plot, just highlight these, insert, and then insert your scatter plot. Okay. You guys should name these if you could, and also put like some titles on the axes. So remember, if you want to do that, just click on this plus, go to axis title. Up here, you could just say residual plot. I don't know why I deleted the word residual, but it seemed like a good idea at the time. And then over here, this would just be the actual residual. And this would be the name of the residual. Okay, so you could just call this residual name. Okay, all right, that's it. Okay, that's literally pretty much the whole assignment. Okay, so it's not meant to be, the first one's probably the toughest of all. Okay, Now, stuff I'm going to ask you guys is to be able to do an analysis. Okay, so the other part, just like on the first assignment, is I'm going to give you guys some questions and you're going to do an analysis. So for instance, like with this one, we can clearly see that they're directly proportional, right? It's a really strong association. Okay, for your assignment, the association may not be as strong. Okay, so you guys are going to have to make that decision whether it's strong, moderate, or weak. And then also to look for any outliers with respect to the residual plot as well. Okay. I want to show you guys really quickly what the assignment looks like because the Excel sheet looks like it's a mess. I want to make sure that you guys know exactly what it is I'm looking for that. Okay, so this is well, I had it. I don't know where it went. It ran away. Maybe it closed out when I brought this up. But anyway, I'm just going to bring it up. All right. So the Excel file, and you guys shouldn't be typing this data in, okay? You guys should be using the Excel file. Now, this is what the Excel file looks like. It's a bunch of baseball stuff, okay? Let me blow this up a little bit so you all can see it. All right. The first one's pretty easy. The first one's given to you, all right? So when I ask you guys to do the first one, okay, what I'm asking you guys to do is to compare the team payroll and the number of wins. Okay, so if you guys look at this, there's a win percentage. You guys don't even have to worry about that column. Oh, sorry. So just ignore this column, okay, like it doesn't even exist, okay, for your guys' data, okay? So really what you guys are going to be doing is you're going to be making a scatter plot for the amount of payroll that a team spends versus the number of wins in particular in 2019, okay? And you guys are going to see whether or not those two things are associated. And you guys would think in professional sports, the more money you spend, the more wins you get, right? You would think that, but it's not always the case. Okay, there's other factors. Now, the second one is the one that students really don't like. Okay, so you guys look at this and you're like, holy cow, look at all this garbage. Okay, what I'm asking from you guys for the second part is I'm asking you to be able to compare this wins above replacement, okay, to on base percentage. Okay, so there's going to be two statistics that I ask you guys to compare, the WAR and the OBP. So really what you guys can do is go to this spreadsheet and towards the end, these are the columns you care about. It's going to be column P and column S. So what I would do, guys, is just delete these two columns and then you could just go ahead. So delete the existing columns. I think it was O and Q or whatever, or Q and R. And then you could just go ahead and just see whether or not there's an association between on base percentage and wins above replacement. Okay. And if for any of you guys that are ever interested in working like in the sports field and doing like statistical analysis for sports, this is like one of the most elementary things they do. And you can make a lot of money. Okay. Like I could probably leave the college. Is this being recorded? It is. I could probably leave the college tomorrow and make like 5 times as much like working in a sports place doing this stuff. Okay. Because they just pay people ridiculous amounts of money to just determine, you know, if a batter's left-handed, do they have a significant advantage against a right-handed hitter? That sort of stuff. So anyway, sounds like a good idea. I'll see you guys later. No, I'm kidding. All right. Any questions, guys, about the assignment itself? Okay. Everybody understands like with the big Excel sheet. And it might be one of those things where once you guys start getting dirty with it, then you guys might have some questions for me. Okay. But that's literally everything that I'm going to ask you guys to do. The questions that I ask, just define the explanatory and the response variable. You guys are really good at that. I don't think anybody got that wrong on the exam or on the quiz. Give me the strength, direction, and association. I think everybody got that right on the quiz and the exam, so that's not that bad. Interpret the correlation coefficient, okay? What that means is, guys, like, remember, if R is like close to 1, it's really strong. If R is like 0.7, 0.5, it's like moderate, and then anything less than 0.5, it's weak. Okay, so go back to that sheet where we did the guided notes with that and just look at that. Do you suspect there's any outliers? Okay, guys, how do we determine if there's any outliers first for bivariate data? We look at what? Which plot? Not the scatter plot, but the residual plot, right, guys? The residual plot helps us to see any outliers, okay? And then finally, overall summarize the association. What you guys are going to do is just say, is there an association or not, by looking at the correlation coefficient in the scatter plot. Okay, so does that make sense to everybody, guys? This one's, like I said, this one's a lot easier than the first one. Okay, the first one's a pain. I get it. But the first one's probably most likely what you guys are going to be doing in real life. Okay. All right, guys. The other thing is I'm going to make this one due not next Tuesday, but the following Tuesday. Okay, so whatever date that is, I got no clue. That's going to be the 27th. So on the 20th, that'll be Tech 1. On the 27th, that'll be Tech 2. Okay. All right. All right. So I'm going to end this.